Hello everyone, my name is Eric. I currently work as an electrical instrumentation and controls engineer based in Chicago, and I also have my bachelor's in electrical engineering. So today's topic we'll be discussing will be in electronics. More specifically, we'll be diving into diodes, what functionalities and what's their purpose, and then we'll also get into a circuits problem where I'll also implement a diode into it as well. So let's get started. So essentially, there's two types of diodes and biases that you should remember and know. And those two will be a forward bias diode and a reverse bias diode. So very quickly, just in terms of what diodes do, essentially they control the flow of currents flowing through them. And essentially in a circuits, how we think of current, we think of it as like the flow of water essentially in a circuit. So in this case, for a forward bias diode, and very quickly as well, the positive side of a diode would be this side, which would be the anode side, and then this would be the cathode. Now, a forward bias diode, another good way of thinking of it, we kind of want to think of it as like a closed circuit. So when we think of a forward bias, we want to imagine that our diode is in closed circuit position. And essentially, you know it's in forward bias in a problem if the VD, in this case, the voltage of the diode, is greater than zero. And if that's true, then what's also true is that the current flowing through that resistor is also greater than zero. Sorry, not through that resistor, through that diode. Now, obviously, for a reverse bias diode, it's going to be the opposite. Obviously, this is still the same in terms of the anode and cathode, it doesn't change. But in the case of a reverse bias, what happens is we actually have to imagine it as an open circuit. And the only way we know it's in reverse bias if its VD value is less than zero. And then, of course, we have to also assume that there's no current flowing. So ID will also be zero as well. So that's how you distinguish the two. And we're going to dive right into a problem involving how we would implement the diode and solve its current flowing through it. Okay, awesome. So essentially, I have a problem here where there's going to be a diode involved with a bunch of voltage sources and resistance. It looks a little bit overwhelming at first, but I'm going to kind of walk you through the thought process that you should have whenever you see a problem like this. So the first thing that you should be going through your mind is obviously understanding what you're trying to do in terms of the question. So in this case, we're trying to identify what the current is flowing through the diode. The next step you want to take is just by looking at the circuit by itself and what we know so far, what do we kind of hypothesize and assume is going on with the diode, right? So if you remember, a forward bias diode, essentially what's happening is we want to say that there's a positive voltage going through it, right? So if you remember for the anode and cathode, this is the anode, this is the cathode of this diode, right? And we see that we have 10 volts coming in through this side, right? So I guess it's safe to assume that there's going to be roughly around 10 volts somewhere around here. And then we see on the other side of the circuit, there's 5 volts. And you can see that the 5 volts goes to a resistor, and then there's also a resistor here. Then we got our node right here, right? So just by looking at this, you can probably assume and hypothesize first that most likely this is going to be a forward bias diode, right? Because you got a positive 10 volts coming from this side, and you have 5 volts coming from this side, which most likely means that this will be forward biased. So that's the first thing. Now, the next thing you want to do is decide whether or not you want to have the diode in an off or off position. So if we assume that the diode is turned on, right, because we're saying that there's most definitely a positive value voltage going through it, then we would make it a closed circuit, right? So we make sure we change it to this thing. But first, let's do the opposite to just identify the reverse first. So what we're going to do is we're actually going to make it an open circuit, and we're going to go from there. Okay, so I essentially changed the diode into an open circuit, and we're going to assume for this situation the diode is turned off, right? So we're going to say that VD in this case is less than zero. And we're going to test this theory out, right? So we're going to keep this open. The 10 volts in this case, we're going to just ignore because right now we're saying it's an open circuit. Let's focus on the other side. We see that there's 5 volts coming in, it goes through the resistor, and then we have a resistor here, right? So if you remember nodal analysis, so let's call this Vx, we're going to try to solve for the voltage for this node to help us kind of figure out what the voltage is going through the diode. So for nodal analysis, what we're going to do is for Vx, we're going to do Vx minus 5 volts over the resistance going through it, which is 1 kilo ohms. And then we also want to add Vx over 3 kilo ohms. And we're going to make that equal to 0. So if we were to break this down further, essentially what we're going to do is we're going to multiply this by 3 in the denominator, which means that we multiply this up numerator by 3. So we get 3Vx minus 15 plus Vx equals 0, which makes that look really nice. And then from here, what we're going to do is we're going to take 4Vx, because we add the 2, minus 15 equals 0. And then we can put the 15 on the other side and the 4Vx here. Divide this by 4. And then from here, we get Vx is equal to 15 divided by 4. So if you have a calculator really quick, you can solve for this. It should be somewhere between 15 divided by 4, 3.75 for the Vx value. So now we know Vx is 3.75 volts, and essentially now all we have to do is subtract 10 volts and the Vx value, which is 3.75, to get the voltage going through the diode. So we get 10 volts minus 3.75, which gives us 6.25 volts for Vd. So essentially, when we have this in an open circuit, right, for the diode, essentially what we found out, and it kind of proved our hypothesis that was right, is that the diode is in forward bias position, right? Because our Vd value is greater than 0. Awesome. So now what we're going to do is I'm going to change the circuit again. We're going to say now that Vd is on, and we're going to go from there. So we can solve for the current flowing through the diode. Okay, so now we have it saying that Vd is on. So in this case, we're going to have the diode in a closed circuit position. And now all we have to do left is figure out what the current is flowing through it, right? So my recommendation is utilizing mesh analysis. So if you remember, we're going to call these loops I1 and call this loop I2. And we just solve for I1, I2. So for this loop, we have 10 volts going through this closed circuit diode, and then we're going to call this plus, minus. Oh, this should be 3 kilo ohms. I don't know where that went. And so we're going to have, let's put it into an equation, so or a function. So we have 10 volts minus 3 kilo ohms times I1 minus the 3 kilo ohms also representing the I2 side, right? So minus 3 kilo ohms times I2, which equals 0. Awesome. And now we're going to solve for the second loop. So we have we're going to make this positive, negative, positive, negative, positive, negative. And so we're going to have this going minus 3 kilo ohms times I2 minus the I1 side, 3 kilo ohms times I1. And then we're going to go through this, the 1 kilo ohm, so minus 1 kilo ohm times I2. And then finally, it goes through the voltage source, which is minus 5 volts. Awesome. And now we can just solve for I1, I2 by making system equations. So to make this easier for us, we're going to put the 10 volts on the other side here. So what we can do is we can make this negative 3 kilo ohms times I1. And then this will be positive 3 kilo ohms times I2. and then the 10 volts will be on the other side, minus 10 volts. And then here we're going to go, we're going to set it up so it's kind of in order, so it's visually easier for us to see. So this will be a positive 3 kilo ohms times I1. And then we have a positive, we have negative 3 kilo ohms. So this is negative plus another negative, so that's 4. So minus 4 kilo ohms times I2, which equals, this bring it to the other side, is 5 volts. Okay, awesome. And so I'm going to stand on the other side. And then from here, what we're going to do is we're going to just solve for I1, I2. So we can see that these cancel out. And now we can solve for just I2 here. So a positive over negative. So we have negative 1 kilo ohm times I2 equals, in this case, negative 5 volts. So we know that the current flowing through I2 is 5 volts because we still have to divide by this by negative. So I2 is, is 5 milliamps, sorry, because we have 1 kilo ohm over volts. So we have I2 equals 5 milliamps. So I2 is 5 milliamps. It doesn't matter which equation you use from here, but let's just use, this one to make it easier for us. So we can plug in 5 milliamps to I2 here. So we're going to go negative 3 kilo ohms times I1 plus 3 kilo ohms, and I2 we just solved, which is 5 milliamps, equals negative 10 volts. So what we're going to do is we're going to take this 15 kilo ohms times milliamps, 15 volts, equals negative 10 volts, and then make this negative 3 kilo ohms times I1. And so we move this to the other side, we get negative 25 volts equals negative 3 kilo ohms times I1. So I1 becomes negative 25 divided by negative 3, which gives us 8.33 milliamps, which makes this statement true because we first found out that VD is greater than 0, so it is in forward bias position. And then we also know that the current has to be greater than 0, and that makes it true because I1 is 8.33 milliamps. Awesome. So there's many layers to this kind of problem. We utilize a lot of things. We first had to identify the functionality of the diode. We had to utilize nodal analysis, mesh analysis. But this is a very good problem to definitely understand and get a fully conceptual understanding of, because you're going to definitely see these kinds of problems throughout your career. So yeah, and hopefully you guys enjoyed the video. If you have any questions or comments, let me know, and take care. Bye-bye.